All right. Okay. Welcome to my channel on Maths Made Easy with Terry in 10 minutes. Okay. In the previous video, I talked about how we make having integral of a special form of derivative. So such that when you differentiate the denominator to give it the numerator, and when you do that, it's going to give you, for instance, it's going to give you the ln of f of x, okay, plus c. All right, talk about this. Good. Now, we have other special cases I want to talk about just to bring to your attention. So if, for instance, we're meant to integrate this dx, right? And you have normally what you would do is that you say bring out the 6 and it's going to become x squared all over x cubed minus 4. Now, but if you look at this, okay, if you look at this closely, all right, look at this closely. When you differentiate x cubed minus 4, it will give you 3x squared. And that is not the same thing as x squared. So that means we can't apply the same principle here to ln. So we cannot just say that this is the same thing as ln x cubed minus 4. We need to play around with the fraction such that when we differentiate the denominator, it's going to give exactly the same thing. So what I would do is that in this case, in order to make it more interesting, I'm going to multiply the bottom and the top and the bottom by 3. So that means I'm going to have 6, I'm integrating 3 over 3 multiplied by x squared all over x cubed minus 4. Now, if you look at this now, I've not changed anything. 3 divided by 3 is 1. Does that make sense? So nothing has changed here. So that will give me, I'll have 6, I'm integrating 3x squared divided by 3x cubed minus 4. All right? So I'll bring out this 3. I'm going to leave this one. I'm going to bring this 3 out. So it's going to be 6 all over 3 integrating 3x squared all over x cubed minus 4. Now we are back. If I integrate x cubed minus 4, I'm going to get what? 3x squared, which is the numerator. And we're back to this form now. So then I can now say 6 divided by 3 is going to become 2. Now, because if I differentiate this, it's going to give me the numerator. Then it's going to become ln x cubed minus 4, okay, plus c. And that's the answer for that. Does that make any sense? So now you can see in this case, it's the same thing we did on the previous video, but in this case, we're trying to play around with numbers here and play around with fractions such that the numerator and the denominator will be the same thing, okay? So usually what I always say is that a quick guide is that if you differentiate this, the extra factor you have here, or the extra constant, multiply up and bottom by this. So like in this case, we have 3x squared, and we have 3x squared here, but what we are looking for is what? X squared. So because the 3 is the extra, I multiply the top, the numerator, and the denominator by this 3 and simplify. Okay? Let me pick another example, okay? So maybe it will make more sense. Let's say we have, we're integrating, okay? Let's say we're integrating x minus 3 divided by x squared minus 6x plus 2, all right? Now, when you differentiate x squared minus 6x plus 2, it's going to give you 2x minus 6. Can you see? But what you're looking for is not 2x minus 6. So for it to be in that form, we are looking out for. We are looking for what? X minus 3. And what is the difference between both of them? It's 2. So that means if I multiply x minus 3 by 2, it's going to give me 2x minus 6. Okay? All right. So what do I do then? Then I will come back to this equation here. I will now say x minus 3 over x squared minus 6x plus 2. In order to make it more interesting, for it to be the same, I'm going to multiply the top and the bottom by what? 2. Can you see? And that will give me x minus 3 divided by x squared minus 6x plus 2. Is this making sense? So you will now see, then I can now say, I'll bring this 2 outside and leave the 2 in the numerator, right? So it's going to give me 1 over 2, we integrate 2x minus 3 divided by x squared minus 6x plus 2. Now, if we open the bracket, okay, it's going to give us 1 over 2. We integrate that. It's going to give us 2x minus 6 divided by 2x, divided by x squared minus 6x plus 2. Now we're back to the form. When I differentiate x squared minus 6x plus 2, it's going to give me the 2 minus what? 6 I was interested in the first place. Okay? So that means I can now write this to be 1 over 2 ln the denominator x squared minus 6x plus 2, okay, plus c. Is this making sense? That is it. The only difference here is that we're going to multiply by a factor or divide by a factor depending on the case you find yourself, such that when you differentiate the denominator, it's going to give you the numerator. Is that okay? All right. Let me pick one more example. Maybe that'll be the last one for this video, so it's going to be more than 10 minutes. Let's say we're integrating tan x, okay? Okay, and we know tan x is equal to, we're integrating sine x over what? Cos x. But if you remember what we talked about in the first video in this series, we said sine, I think it's sine, cosine, minus sine, and minus cosine. Now, when you differentiate cos, it's going to give you minus sine, but not sine. Does that make sense? When you differentiate cos, it's going to give you minus sine, not sine. So that means we need to play around with this. So that means what I can do is that minus is what is the missing thing here. I can multiply both denominator and the numerator by minus 1. So minus 1 multiplied by minus 1, sine x divided by what? Cos x. Okay? I bring this minus 1 out and leave the minus. So it's going to be minus, we integrated, minus sine x divided by what? Cos x. Can you see? So when I differentiate cos x this time, I'm going to get minus sine x. So with this now, I can now say it fulfills the form of the f prime x, f of x equal to the ln f of x plus c. Does that make sense? So it fulfills the form. So that means I can now say it's going to be minus ln cos x plus what? C. And that will be the answer to that. Okay. So yes, so that will bring me to the end of this form. All right. That is that for that. So basically, what you need to do is that when you have any part kind of question like this, regardless, and you see the denominator does not give you exactly the same answer as the numerator, what you have to do, you have to look for a constant value. It could be minus 1, it could be 2. You have to multiply the numerator and denominator such that when you play around with it and you try to rearrange the fractions, you will get the same way that you differentiate the denominator. It will give you the numerator, okay? So that was that for that. The next video, I'm going to talk about when you have something like this. So f of f prime x. So remember, in this video, it was f prime x divided by what? F of x. Does that make sense? That gave us ln f of x plus c. Does that make sense? So what we talked about in this video, right? Now, but the next video now is what happens, how we differentiate when you differentiate the first one, the first function, and it gives you the second function, okay? I'm going to talk about in the next video. So please feel free to like, share, and comment, okay? Please make sure you subscribe so when I upload new videos, you can get notification for it. All right, thank you very much, and I will see you in the next video where we talk about this kind of integral forms and how do we solve it. All right. I'll see you very soon.